Okay, great. So we have a way for people to get money in. How do they get their money out? So we're going to need to write this redeem collateral, right? So in order for them to redeem collateral, let's talk about this. In order to redeem collateral, they need what? One, their health factor must be over 1 after collateral pulled. So we're going to want to put some checks in here to make sure that they have enough money in here. And that's kind of the main thing, right? That's all we really need to worry about. So let's go ahead and start writing this. So first we should let them choose which collateral they want. So address, token, collateral, address, and then obviously the amount collateral. And we're going to want to add this more than 0 modifier in here for the amount collateral. We don't want them to be sending accidental 0 transactions. And because we're going to be moving tokens around, we'll just do non-reentrant. Better safe than sorry. We can figure out later in kind of like a gas audit if this is even needed. Now I'm going to write this function as if somebody redeeming collateral is the only time they actually redeem collateral. However, we're going to refactor this in the future to make our code much more modular. There's this concept in computer science called dry. Don't repeat yourself. If you find yourself coding the same thing, that should send off a light bulb in your head going, oh, maybe what I'm doing isn't the best practice. So we're going to code this one way, and then I'm telling you right now, we're going to go back and we're going to refactor this in the future. But I want to code it this one way first, just to show you the process that you'll probably go through and how you'll probably refactor it when you come across this yourself. So we're going to code this one way now. Let's do it. We're going to need to pull the collateral out, and we're going to update our internal accounting. So we have this s underscore collateral deposited of message.sender of the token collateral address, right? This is our internal accounting, how much collateral they've added. We're going to do minus equals amount collateral. So this is assuming we're going to pull it out. If they try to pull out more than what they have, we're relying on the Solidity compiler a little bit to throw an error, right? If in their balance they have 100 and they try to pull out 1,000, right, it'll revert. Because as of newer versions of Solidity, they don't let you do this unsafe math stuff, which is awesome. It saved us a lot of hassle. So, and then since we're updating state, we're going to emit an event. Let's call it collateral redeemed. We'll say it's message.sender. So from message.sender, the amount collateral, the token collateral address like this. So we're going to go to the top. We're also going to refactor this event, but you'll understand why later. Event collateral redeemed, address indexed, user, address indexed, token, uint 256 indexed, amount, like this. Okay. Control minus, go right back down to where we were. Okay, amount collateral. Oh, what's wrong with this? Oh, these are backwards. Okay, cool. So now all we have to do is return the money. Well, how do we do this? So we want to follow CEI, right? Checks, effects, interactions. Checks, effects, interactions. But we also want to make sure the health factor is good after collateral is pulled. And this is where sometimes you'll see CEI be violated. When I need to check something after a token transfer has happened, sometimes you'll see this CEI be violated a little bit. And what you could do is you could do like calculate health factor after and then like simulate it. But a lot of people choose to not do this because this is really gas inefficient. So what a lot of people do is they just go ahead with doing the token transfer first and then checking this and reverting if this happens. And that's usually fine though, because we're going to revert the transaction if it's bad, right? So what we'll do is we'll do this token transfer and then we'll make sure the health factor is okay. So you know how to move tokens around. So we'll say bool success equals IER20 token collateral address dot. We can just do transfer instead of transfer from, since transfer is when you transfer from yourself. Transfer from is when you transfer from somebody else. So dot transfer, and we're going to be sending it to message.sender. And we're going to send amount collateral. And then if not success. If not success, we're just going to go ahead and revert. DSC engine, we'll just do transfer failed like this. And then we want to make sure that the health factor isn't broken. And we have written a function that does that already called revert if health factor is broken. So we can just grab this, go back up to our redeem and just do revert if health factor is broken for the message.sender. Okay, cool. Like I said, we're going to refactor this very soon. Okay, but it looks like this is actually pretty good for redeeming collateral. Now, this revert if health factor is broken is a little bit troublesome with just this raw redeem collateral. Let's say I put $100 in and then I mint, let's say $20 worth of DSC. Put $100 worth of ETH in and I mint $20 worth of DSC. Let's say I'm done. Like I want to burn all my DSC and I want to withdraw all of my ETH. Well, if I try to redeem all my ETH, it'll break, right? It'll break my health factor. So what I need to do first is I need to first burn back my DSC and then I need to redeem ETH. So it's a kind of this 2-transaction process here. This kind of stinks. So let's turn it into a 1-transaction process. So we're going to combine redeeming your collateral with also burning your DSC, which means we're going to need to create a burn DSC function. And we're also going to refactor this in a little bit, but I'm just going to write it as if this is the only burn DSC function for now. So let's have people burn their DSC, right? This is when they say, hey, I'm done with these tokens. And this will reduce that. If we scroll up to the top, we have this mapping here, SDSC minted, it'll reduce this SDSC minted. So essentially it'll reduce their debt in the system. So burn DSC, we're going to add some modifiers here. This should be more than 0. Amount. So we want to do a U256 amount so they can burn as much as they want. And then what we're going to want to do is we're going to say S_DSC minted of the message.sender is going to minus equal amount. So we're going to remove that debt, remove that DSC minted. And then we're going to do a little bool success equals I_DSC dot transfer from DS message.sender to address this amount. And we could also send this to the 0 address, but we're going to just send it to our address for now because the decentralized stablecoin ERC20 burnable has its own burn function. And we're just going to call the burn function directly on the token itself. But first, we're going to take it from them, bring it into our contract, and then we're going to burn it. So if not success, then we'll revert DSCE transfer failed like this. And this conditional is kind of hypothetically unreachable because if the transfer fails up here, we're going to throw the transfer from fail error. But let's say this DSC token is implemented wrong. Great. We kind of have this backup. But so they're going to send their DSC token here. Then we're going to call IDSC.burn amount. Now, since we're burning DSC, question is, do we need to check if this breaks health factor? Well, probably not, right? Because we're burning DSC, we're burning debt. It's highly unlikely that burning your debt, removing your debt is going to break the health factor, right? We probably don't ever need this, but I'm just going to add this in here for now, just as a backup. In a gas audit, we can figure out if we actually need it. I don't think this would ever hit. And this is where, when I do go to an audit, when I do go to a security professional, I can make sure to point this line out. Say, hey, I don't think this line will ever hit, and I'm thinking of pulling it out. What do you think? Right? It's good to call these out in your comments so that when you do go to a professional who knows, they can help you out, figure this out. So for now, we're going to put it in here, although it's highly likely we don't even need this. And we're going to refactor this function pretty soon anyways. So we have this burn DSC function. We're going to make it public because we're going to be burning DSC and redeeming collateral at the same time. So now we have redeem collateral. We have burn DSC. Now we can write this redeem collateral for DSC, where we send DSC and redeem collateral at the same time. And so in here, we're going to say address, token collateral address. uint 256 amount collateral, uint 256 amount DSC to burn. We'll have this be external. So then we're going to call burn DSC with the amount of DSC to burn. We're also going to call redeem collateral. So we're going to burn the DSC first, and then we're going to redeem their collateral with the token collateral address and the amount collateral. Redeem collateral. Oh, this is external. Let's make this public. Let's go back. And then, of course, we should revert if health factor is broken. But if we look, our redeem collateral function currently does this already. So we don't need to do that here. So I'm just going to put this comment. Redeem collateral already checks health factor right here. And then we'll add a little bit of nat spec here. So at param, boom. That's not even the right param. Token collateral address, the collateral address to redeem at param. Amount collateral, the amount collateral to redeem, at param, amount DSC to burn, the amount of DSC to burn. This function burns DSC and redeems underlying collateral in one transaction. Okay, cool. Are we going to refactor these two functions soon? Yes, absolutely. But I want you to understand why we're going to refactor them. So we're going to leave them in as they are for now.